about how to figure out electron configurations for any atoms, for any atom on the periodic table. We probably won't do any of the really gigantic ones like lead or uranium-238, but we're gonna do a lot of different elements. The way that their electrons are configured completely determines how they'll bond, what they'll bond with, what kind of ions they'll form. So all their characteristics are fundamentally determined by what kind of electron configuration they have. There are rules for electron configuration. There are only 3 rules, and they're easy to follow. So the first one is Aufbau. Aufbau is German, of course. And this just says that when you've got an electron that's going to be around an atom, it's going to go to the lowest possible energy level. Lowest energy level that has an open spot. So the metaphor for this is as follows. You are all going to pack off and head to college in a couple of years here, some of you in the next year. When you do, you're probably going to hit dorms. So you've arrived at your college dorm with all of your belongings strapped to your body, your refrigerator tied to your head, your books, your book bags, your clothing, your pet hamster, I don't know what you're taking with you. A bunch of stuff. And you walk up to the dorm, and it's a 10-story high-rise dorm with no elevator. So, my question is, if you walk into that first floor and there's an empty available room, are you climbing to the second floor? Nope. So, that's all we're saying, is that that electron that arrives at its dorm with all its belongings strapped to its body is not going to climb any stairs that it does not have to. You take the lowest energy level available. So the first electron always goes in what orbital? 1s. Not just s, 1s. 1s is the very first lowest energy level available. Now, what do you think has got a little bit more energy than 1s? 2s. Yeah. So we're just going to the second floor. Okay, that's easy. And then we know that p's come after s's, right? So what has a little bit more energy than 2s? 2p. Okay, this is easy. Okay, great. We just count. We can count, Moser. So what would have, but can we? If not, what would have more energy than 2p? 3s. Okay. And then it gets weird. And then you make a big chart. Have you guys made the big chart before?
Nope.
Okay, good. You get to learn something new, the big chart.
The chart that we did yesterday?
No, it's a new chart.
Is it a worse chart?
No.
Alright, because I cannot draw.
And you're going to learn to draw, you're going to draw this chart again and again and again and again. You're probably going to want to get it tattooed on your inner arm. You may want to get it on a t-shirt. You may want to paint it on all of your fingernails. You may want, yeah, you know, that on one side, periodic table on the other.
Yeah,
sure.
Just don't get it on the back.
Okay, so that's the chart right there. And while you're taking a gander at that, I'm going to draw this one on the board. I would recommend that you draw this for yourself in your notes because it's different drawing it than just seeing it. So we draw it by putting our 1s, below that is 2s, then 2p, then 3s, then 3p, then 3 what? D. 4s, 4p, 4d. At the D level, at the fourth main energy level, what new orbital shape do we get? F.
Oh.
4f. 5s. 5p, 5d, 5f. We could go out to 5g. We never do because we don't really deal with atoms that are that big. 6s, 6p, 6d, 6f, 7s, 7p, 7d, 7f. Okay, so that's the first battle. Now, the chart on your notes and up there doesn't go out to 6F and 7F. Actually, doesn't even go to 7B. The only reason for that is we seldom fill those. What? We seldom fill 7F, 6F, 7D, 7F. So the chart there doesn't go out that far, but of course they exist. I mean, heck, we could go out to 5G, 6G, 7G. They exist, we just don't really play with those. So now, you've got this nice triangle design. You're going to draw this repeatedly.